Hello all, welcome to the final section, Sending Data with Ajax. In this section we'll cover loading data from the server without a page refresh, sending data from JavaScript in the browser back to the server, interpreting data in a variety of formats including HTML, XML and JSON, providing feedback to the user about the status of an Ajax request. Now we move on to the first video, loading data on demand. In this video, we're going to see how data takes many forms by performing the same basic task using different approaches. Before we start working with Ajax, we'll first install Node.js. Once this is done, we'll initialize the server. Traverse to the project directory and add this command. This will ask you a bunch of questions, and then write a package.json for you. It attempts to make reasonable guesses about what you want things to be set to, and then writes a package.json file with the options you've selected. If you already have a package.json file, it'll read that first, and default to the options in there. Now we'll give a name to our initialization, that is 06. The version is already selected. Give it as test, and keep pressing enter. So the instances have been created and are stored in package.json files. Press Y and our package.json files are created. This contains all this information. We next add this line in the file, and then add some dependencies on our server. For this, we use npm install body parser command. The body parser object exposes various factories to create middlewares. So press enter to install it. And you can see the body parser has been installed. Next, we'll install a dependency for Express. For this, we use this command. Some of the features are robust routing, focus on high performance, super high test coverage, and much more. We'll now install it by pressing enter. As you can see here, it's got installed. You can also see that the Node modules are installed in our project after installing these dependencies. To start the server, we create a file named server.js and add this code. This block is useful for starting the server. You'll understand more about this part towards the end of this video. Save these changes and start the server. For starting the server, we use this command. As you can see, the server has started on localhost 3000. We're going to build a page that displays entries from a dictionary, grouped by the starting letter of the dictionary entry. For this, we create a new index.html file and add this code. The HTML defining the content area of the page will look like this. Our page will have no content to begin with. We're going to use jQuery's various Ajax methods to populate this div tag with dictionary entries. We're going to need a way to trigger the loading process, so we've added some links to our event handlers to latch onto. These simple links will lead us to pages that list the dictionary entries for that letter. We'll use progressive enhancement to allow these links to manipulate the page without a full page load. We create a new style sheet named 06.css and add this code. This code has many style formats. We refer this to our index file and run the index.html file. With basic styling applied, this HTML will produce a page that looks like this. Now we can focus on getting content onto the page. You can see that we've executed the HTML file on our server. So you just need to type the localhost and port number to run our code. Ajax applications are often no more than a request for a chunk of HTML. This technique, sometimes referred to as asynchronous HTTP and HTML, AHAH, is almost simple to implement with jQuery. First, we need some HTML to insert. which we'll place in a file called a.html alongside our main document. Here we add this content. The page continues with more entries in this HTML structure. Rendered on its own, a.html is quite plain. Note that a.html is not a true HTML document. It contains no HTML, head or body tag, all of which are normally required. We call such a file a partial or fragment. Its only purpose is to be inserted into another HTML document, which we'll do now. Before we add any JavaScript, let's add jQuery to our project file, as we're running everything on the server. We need jQuery file inside our project file, rather than previous jQuery file. Let's add a JavaScript file named 6.0.js and the code. The .load method does all the heavy lifting for us. We specify the target location for the HTML snippet using a normal jQuery selector, and then pass the URL of the file to be loaded as a parameter. We'll add reference of this file inside our index file and run our index.html file. Now, when the first link is clicked, the file is loaded and placed inside. The browser will render the new HTML as soon as it's inserted. You can see that this content is inserted dictionary inside using developer tools. Note that the HTML is styled. This is due to the CSS rules in the main document. As soon as the new HTML snippet is inserted, the rules apply to its elements as well. When testing this example, the dictionary definitions will probably appear instantaneously when the button is clicked on. This is a hazard of working on our applications locally. It's hard to account for delays or interruptions in transferring documents across the network. Suppose we added an alert box to display after the definitions are loaded. For this, we create a JavaScript file named 6.1.js and add this code. We've added alert method after the load method. We'll add reference of the file in our index.html and refresh the page. As you can see, once we click on a button, an alert comes and goes quickly. Before the load has been performed, JavaScript execution is synchronous, working on one task after another in strict sequence. However, when this particular code is tested on a production web server, the alert will have come and gone before the load is completed, due to network lag. This happens because all Ajax calls are by default asynchronous. Asynchronous loading means that once the HTTP request to retrieve the HTML snippet is issued, script execution immediately resumes without waiting. Sometime later, the browser receives the response from the server and handles it. This is the desired behavior. It's unfriendly to lock up the whole web browser while waiting for data to be retrieved. Pulling in fully formed HTML on demand is very convenient, but it means having to transfer a lot of information about the HTML structure along with the actual content. There are times when we would rather transfer as little data as possible and process it after it arrives. In this case, we need to retrieve the data in a structure that we can traverse with JavaScript. With jQuery selectors, we could traverse the HTML we get back and manipulate it, but a native JavaScript data format involves fewer data to transfer and less code to process it. Retrieving JSON. As we've often seen, JavaScript objects are just sets of key-value pairs and can be defined succinctly using curly braces. JavaScript arrays, on the other hand, are defined on the fly with square brackets and have implicit keys, which are incrementing integers. Combining these two concepts, we can easily express some very complex and rich data structures. The term JavaScript Object Notation, JSON, was coined by Douglas Crockford to capitalize on this simple syntax. This notation can offer a concise alternative to the bulky XML format. While based on JavaScript object literals and array literals, JSON is more prescriptive about its syntax requirements and more restrictive about the values it allows. For example, JSON specifies that all object keys as well as all string values must be enclosed in double quotes. Also, functions are not valid JSON values. Because of its strictness, developers should avoid hand-editing JSON and instead rely on software such as a server-side script to format it properly. We can encode our data using this format in many ways. To illustrate one approach, we'll place some dictionary entries in a JSON file. For that, we create a file called b.json and add this code. To retrieve this data, we'll use the $getJSON method, which fetches the file and processes it. When the data arrives from the server, it's simply a text string in JSON format. The $getJSON method passes this string and provides the calling code with the resulting JavaScript object. Up until this point, all jQuery methods that we've used have been attached to a jQuery object that we've built with the $function. These selectors have allowed us to specify a set of DOM nodes to work with, and the methods have operated on them in some way. This $getJSON function, however, is different. If $were a class, $getJSON would be a class method. For our purposes, we'll refer to this type of method as a global function. In effect, they're functions that use the jQuery namespace so as not to conflict with other function names. To use this function, we pass it the file name as before. We create a new JavaScript file and add this code. We've passed b.json. Let's refer to this in our index file and run it. This code has no apparent effect when we click on the link. The function call loads the file, but we've not told JavaScript what to do with the resulting data. For this, we need to use a callback function. For this, we create another JavaScript file, 6.3.js, and add this code. The $getJSON function takes a second argument, which is a function to be called when the load is complete. The callback function also takes an argument, which is filled with the resulting data. Inside this function, we use the data parameter to traverse the JSON structure as necessary. We'll need to iterate over the top-level array, building the HTML for each item. So we create another JavaScript file, 6.4.js, and add this code block. We've used the reduce method of the data array to turn it into an HTML string that we can then insert into the document. The reduce method takes a function as an argument and returns a section of the result for each item in the array. We use a template string to build the HTML content for each array item. The resulting argument is the value from the previous array item. Using this approach, it's a lot easier to see the HTML structure than would otherwise be using string concatenation. Once all of the HTML has been built for each entry, we insert it into div id equals dictionary with .html, replacing anything that may have already been there. Add the reference on our HTML page and refresh the HTML page. All that's left is to handle the entries with quotations, so we create another JavaScript file and add this code. We've implemented a couple of helper functions that use the reduce technique to build a string. We refer this file in our HTML page and refresh the web page. With this code in place, we can click on the B link and confirm our results. The dictionary entries are displayed on the right-hand side of the page as expected. The JSON format is concise but not forgiving. Every bracket, brace, quote, and comma must be present and accounted for, or the file will not load. In some cases, we won't even get an error message. The script will just silently fail. Pulling in a script is about as simple as loading an HTML fragment. We create another JavaScript file, 6.6.js, and add the code. In this case, we've used the $getScript function, which accepts a URL locating the script file. In our last example, we needed to process the result data so that we could do something useful with the loaded file. With a script file, though, the processing is automatic. The script is simply run. Scripts that are fetched in this way are run in the global context of the current page. This means they have access to all globally defined functions and variables, notably including jQuery itself. We therefore mimic the JSON example and prepare and insert HTML on the page when the script is executed. So we create c.js and add this code. Add reference of this file in our index file and refresh the page. Now, clicking on the C link has the expected result, showing the appropriate dictionary entries. Next, we'll be loading an XML document. XML is part of the acronym Ajax, but we haven't actually loaded it in XML yet. Doing so is straightforward and mirrors the JSON technique closely. First, we'll need an XML file, d.xml, containing some data we wish to display. So we'll create an XML file named d and add the code for the content we wish to display. This data could be expressed in many ways, of course, and some would more closely mimic the structure we established for the HTML or JSON used earlier. However, we're illustrating some of the features of XML designed to make it more readable to humans, such as the use of attributes for term and part rather than tags. We'll start off our function in a similar manner. Create a JavaScript file, 6.7.js, and add the code. This time, it's the $get function that does our work. In general, this function simply fetches the file at the supplied URL and provides the plain text of the callback. However, if the response is known to be XML because of its server-supplied MIME type, the callback will be handed to the XML DOM tree. Fortunately, as we've already seen, jQuery has substantial DOM traversing capabilities. We can use the normal .find, .filter, and other traversal methods on the XML document just as we would on HTML. So create another JavaScript file, 6.8.js, and add this code. We'll refer this file in our index file and run it. When the D link is clicked, this has the expected effect. This is a new use for the DOM traversal methods we already know, shedding some light on the flexibility of jQuery's CSS selector support. CSS syntax is typically used to help beautify HTML pages, and thus selectors in standard .css files use HTML tag names, such as div and body, to locate content. However, jQuery can use arbitrary XML tag names, such as entry and definition, just as readily as standard HTML ones. The advanced selector engine inside jQuery facilitates finding parts of the XML document in much more complicated situations as well. For example, suppose we wanted to limit the displayed entries to those that have quotes that, in turn, have attributed authors. To do this, we can limit the entries to those with the nested quote elements by changing entry to entry:has quote. Then we can further restrict the entries to those with author attributes on the quote elements by writing entry has quote author. This line in listing 6.8 with the initial selector now reads. Let's look at the changes. Refresh the page. This new selector expression restricts the returned entries correspondingly. While we can use jQuery on XML data that's returned from the server, the downside is the size of our code has grown considerably. That's all. We loaded data in this video,